When most people hear the term black hole, they immediately picture a terrifying cosmic vacuum cleaner devouring everything in its path. The image is dramatic: stars, planets, even light itself spiraling into a bottomless abyss from which nothing returns. Yet this popular view only captures one side of the story. While it is true that black holes are the most extreme examples of gravity in our universe, it is equally true that their role in shaping the cosmos is far more constructive than destructive. In fact, black holes may be among the most important architects of structure and order in the universe. They are not merely wrecking balls tearing apart the stars, they are the hidden pillars around which galaxies form, grow, and evolve. They are cosmic sculptors, silent yet influential, directing the rhythm and shape of creation itself. To grasp this architectural role, one must first understand the nature of gravity, because black holes represent gravity pushed to its absolute limit. Gravity is not simply a force that pulls objects together. According to Einstein's general theory of relativity, gravity is the warping of space and time itself. Every object bends space-time to some degree, from a pebble on Earth to the Sun at the center of our solar system. But black holes take this curvature to the extreme. They carve wells so deep in the cosmic fabric that the geometry of reality itself changes. Their event horizon, the boundary around them, represents a line past which nothing, not even light, can return. Yet this extreme gravity also reaches outward, influencing objects far away, controlling the motion of stars, gas, and dust, and even regulating the birth of new suns. Consider the structure of galaxies. For decades, astronomers puzzled over why galaxies formed in the shapes they did. Why do some galaxies spiral gracefully, others appear elliptical, and some take on strange, irregular forms? The clue lies in the hidden giants at their centers, supermassive black holes. These monsters, weighing millions or even billions of times the mass of our Sun, exert gravitational influence over vast distances. Observations using space telescopes have revealed that nearly every large galaxy has one such supermassive black hole at its core. Our own Milky Way houses Sagittarius A*, a black hole 4 million times the mass of the Sun. Far from being irrelevant, these central black holes appear to play a decisive role in shaping the growth and life of their host galaxies. One of the most striking discoveries in modern astrophysics is the correlation between the mass of a supermassive black hole and the properties of its galaxy. Specifically, the velocity of stars orbiting in the central bulge of a galaxy is closely tied to the size of its central black hole. This relationship suggests that galaxies and their black holes evolve together, locked in a delicate cosmic dance. It is as though the black hole provides a kind of gravitational anchor, organizing the stars, gas, and dust into coherent forms, preventing chaos and disorder. Without these anchors, galaxies might not even hold themselves together long enough to form planets, solar systems, and ultimately life. But the architectural role of black holes does not end with mere structure. They also regulate the flow of energy within galaxies. When matter falls toward a black hole, it does not simply vanish. Instead, it forms an accretion disk spiraling inward at near light speeds, heating up through friction to unimaginable temperatures and releasing torrents of radiation. In many cases, black holes also power colossal jets that shoot out particles across intergalactic space at relativistic speeds. These jets can stretch for hundreds of thousands of light years, injecting energy into the surrounding medium. This process, known as feedback, plays a crucial role in shaping galaxies. By heating up gas clouds and blowing material away, black holes prevent galaxies from forming too many stars too quickly. Without this feedback, galaxies would collapse under their own gravity, burning through their fuel in a brief cosmic firestorm, leaving behind lifeless husks. Instead, black holes meter out energy, slowing down star formation and ensuring galaxies remain active for billions of years. In this sense, black holes act almost like regulators or thermostats, balancing creation with destruction to sustain cosmic ecosystems. Imagine for a moment a city without planners, without traffic signals, without central control. The streets would soon fill with chaos and the city would collapse into dysfunction. Black holes play a similar role in the cosmic cityscape. They provide invisible order, ensuring that stars are not born recklessly, but instead at a pace that allows galaxies to thrive. They keep balance between abundance and scarcity, preventing the cosmic equivalent of overcrowding. Their influence extends far beyond the immediate region around them, shaping not just their host galaxies, but also the web of structure that binds the universe together. If we zoom out from individual galaxies to the vast cosmic web, the architectural role of black holes becomes even more striking. Galaxies are not isolated islands, but are linked together by filaments of dark matter and gas, forming the largest structure known to science. The growth of these cosmic structures is influenced by energy injected into intergalactic space by black hole activity. The jets and outflows powered by supermassive black holes spread matter and energy across millions of light years, redistributing elements forged in stars and spreading them into regions where new galaxies will form. In this way, black holes act as cosmic gardeners, seeding the universe with the raw materials for future creation. They spread the building blocks of life, carbon, oxygen, nitrogen, beyond their home galaxies, ensuring that the story of creation continues on a larger stage. There is also a profound philosophical dimension to seeing black holes as architects rather than destroyers. We are accustomed to associating darkness with endings, with death, with annihilation, but in the cosmic theater, darkness is often the companion of creation. Just as a seed must be buried in the dark earth before it grows, black holes conceal the beginnings of order within their shadow. They remind us that not all shaping forces are visible, that some of the most important influences in life are hidden, silent, and intangible. For billions of years, black holes have been at work, unseen, yet their fingerprints are everywhere, in the spiral arms of galaxies, in the arrangement of stars, in the delicate balance of energy that allows life itself to exist. Our own existence may owe itself to this hidden architecture. If the Milky Way had formed differently without the regulation of Sagittarius A*, our galaxy might have burned out long ago. Without the energy outflows that prevented runaway star formation, the delicate conditions necessary for life on Earth might never have emerged. In this sense, we are the children not only of stars, as Carl Sagan once said, but also of black holes. They shaped the galaxy that shaped us. They carved the stage upon which the drama of life could unfold. Every breath we take, every star we see in the night sky, is a reminder of their silent, unseen influence. Furthermore, the concept of black holes as architects stretches our imagination beyond the visible universe. Some scientists have speculated that black holes may even give rise to entirely new universes. According to certain cosmological models, the singularity at the heart of a black hole could represent not just an endpoint, but also a new beginning, a seed for another cosmos. If this is true, then black holes are not just shaping our universe, but perhaps creating countless others. They would be the wombs of universes, endlessly giving birth in an infinite cycle of creation. While this idea remains speculative, it underscores the possibility that black holes are not just incidental features of reality, but fundamental mechanisms of cosmic design. The more we study black holes, the more they defy their reputation as mere destroyers. They are not cosmic villains, but cosmic architects, builders of order amid chaos, regulators of energy, spreaders of elements, anchors of galaxies, and perhaps even creators of universes. They demonstrate that what seems like an ending can also be a beginning, that what looks like darkness may contain the seeds of light. They teach us that the universe is not built solely by forces we can see and understand, but also by forces that remain mysterious, forces that dwell in shadow yet shape everything we know, and perhaps that is the greatest lesson of all. Just as black holes silently shape the universe without revealing themselves to the naked eye, so too in our own lives the most powerful influences are often unseen. Love, memory, hope, grief, all are invisible, yet they carve the shape of our personal galaxies. The architecture of the cosmos, with its black holes and galaxies, mirrors the architecture of the human spirit. Both are shaped by forces we cannot fully comprehend, but whose presence we can feel in the patterns around us. So, when we look up at the night sky and imagine the unseen giants at work within it, let us remember that black holes are not simply the end of the story. They are its silent architects, hidden hands shaping the stage upon which all cosmic drama unfolds. They remind us that destruction and creation are often two sides of the same coin, and that sometimes the greatest builders are those we cannot see. The universe as we know it, with all its galaxies, stars, planets, and the fragile miracle of life, is not merely written in light. It is equally written in shadow, sculpted by black holes, the most mysterious and perhaps the most essential architects of all. At the heart of nearly every galaxy we have ever observed lies a mystery so massive, so profound, that it challenges our very understanding of what the universe is and how it works. These are the supermassive black holes, colossal entities that anchor the centers of galaxies with masses ranging from millions to billions of times that of our Sun. They are not incidental features, not rare or unusual outliers, but fundamental components of galactic life. Their presence is so consistent across the cosmos that astronomers now consider them essential to understanding the very existence of galaxies themselves. To speak of galaxies without speaking of their central black holes is to tell a story with the most important character missing, for these titanic objects do not merely sit silently in the middle of galactic cities. They shape their growth, regulate their energy, and guide their destinies. To appreciate the scale of these black holes, consider the one nearest to us, Sagittarius A*, at the center of the Milky Way. This black hole is about 4 million times the mass of the Sun, yet it is confined within a region smaller than the orbit of Mercury. For years it remained invisible, hidden behind clouds of dust and stars, until technological advances allowed scientists to detect the radio emissions from its surroundings and even capture the faint glow of matter orbiting near its event horizon. In 2022, humanity saw the first direct image of Sagittarius A*, revealing not a monster but a glowing ring of light around a dark center, a silent reminder that we live in a galaxy dominated by an unseen giant. And this is not unique to us. In fact, every large galaxy examined to date contains a similar presence at its core. The sheer universality of this fact suggests that the formation of galaxies and the formation of supermassive black holes are not separate stories but parts of the same grand narrative. The connection between galaxies and their central black holes is written in the stars themselves. Astronomers have discovered a remarkable relationship known as the M-sigma relation. The mass of the black hole in a galaxy's center is closely correlated with the velocity of the stars moving in the galaxy's bulge. This is astonishing because the black hole is tiny compared to the galaxy as a whole, often making up less than 0.1% of its total mass. And yet, this small central object exerts influence over stars tens of thousands of light years away, as though the entire galactic system somehow knows of the size of its black hole. It is like a city whose population and infrastructure are mysteriously tied to the size of the central plaza. This relationship implies coevolution. Galaxies and their supermassive black holes grow together, shaping one another in a dance that spans billions of years. How does a black hole shape something so large and complex as a galaxy? The answer lies in the extraordinary processes that occur when matter falls toward it. Supermassive black holes are often surrounded by swirling accretion disks, where gas and dust spiral inward, heating up to millions of degrees. These disks shine brighter than entire galaxies, releasing intense radiation and sometimes driving powerful jets that shoot material across vast distances. This activity transforms the black hole into what astronomers call an active galactic nucleus, or AN. Far from being passive consumers of matter, these black holes become engines of energy, blasting their surroundings with outflows that can either nurture or stifle star formation. When the jets and winds from an AGN sweep through a galaxy, they can compress gas clouds, sparking the birth of new stars, or if the energy is too intense, they can blow away the raw material for star formation, shutting it down entirely. In this way, supermassive black holes serve as regulators, determining whether a galaxy becomes a vibrant nursery of stars or a quiet, aging system where new suns are rare. Consider the quasar, one of the brightest phenomena in the universe, powered by matter falling into a supermassive black hole. Quasars can shine so brilliantly that they outshine their host galaxies, visible across billions of light years. The discovery of quasars in the 20th century was a turning point in astronomy because it revealed that black holes, far from being invisible voids, could dominate the energy output of the cosmos, and quasars were not just rare freaks of nature. In the early universe, they were common, suggesting that black holes played a critical role in shaping the galaxies that formed during those early epochs. The fact that we see fewer quasars today implies that as galaxies matured, their central black holes settled into quieter states, no longer ravenous with the same intensity, but still exerting quiet authority over their surroundings. In our own Milky Way, Sagittarius A** is relatively quiet, consuming little material compared to its quasar cousins. Yet even in its calm state, it remains the gravitational anchor of our galaxy. Without it, the orbits of stars near the center would be chaotic, and the balance of forces that shapes the galactic disk would be disrupted. Observations of stars orbiting close to Sagittarius A** have provided some of the most direct evidence of black holes' existence, as astronomers tracked stars whipping around an invisible object at speeds of thousands of kilometers per second. These stars, dancing in tight ellipses, confirm that an enormous but compact mass lies at the center, leaving no explanation other than a supermassive black hole. The precision of these measurements has been so profound that they even allowed scientists to test Einstein's theory of relativity under extreme conditions, finding that his predictions still hold true. Thus, Sagittarius A** is not only the heart of our galaxy, but also a laboratory for testing the deepest laws of physics. Beyond individual galaxies, the influence of supermassive black holes extends into the intergalactic medium, shaping the large-scale structure of the universe. When jets and winds from active black holes blast into surrounding space, they spread heavy elements created in stars into the cosmic environment. These elements, carbon, oxygen, nitrogen, iron, are the building blocks of planets and life. Without the distribution of these materials by black holes, many regions of the universe would remain chemically barren, unable to form complex structures. In this sense, supermassive black holes are not just galactic anchors but cosmic distributors, spreading the ingredients for creation far beyond their immediate neighborhoods. Their reach is measured not in light years but in millions of light years, linking the fates of galaxies across the cosmic web. The story of supermassive black holes also carries profound implications for our understanding of cosmic history. One of the greatest mysteries in astronomy is how such enormous black holes formed so early in the universe's timeline. We have observed quasars that existed less than a billion years after the Big Bang, powered by black holes billions of times the mass of the Sun. How could such massive objects have formed so quickly when the universe was still young? Did they grow from the collapse of the first stars, or were they seeded by exotic processes we have yet to understand? This question touches the heart of cosmology because it suggests that black holes were not afterthoughts in cosmic evolution, but key players from the very beginning. Their rapid growth may have guided the formation of the first galaxies, influencing the distribution of matter on the largest scales. The universality of supermassive black holes suggests a pattern, a kind of cosmic rule that galaxies cannot escape. Wherever stars and gas gather to form a large system, a black hole seems to emerge at the center. It is as though the universe insists on placing an anchor at the heart of every galactic city, ensuring that gravity's extremes always sit at the core. This raises profound philosophical questions. Are black holes inevitable outcomes of galactic evolution, or are they the very reason galaxies exist in the first place? Do galaxies form around black holes, or do black holes form inside galaxies? The truth may be that both processes occur simultaneously, intertwined in a way that defies simple cause and defect reasoning. They are co-creators, partners in building the structures we see when we look into the night sky. Even our understanding of time and space is shaped by the presence of supermassive black holes. The curvature they impose on their surroundings is not confined to the stars nearby, but extends outward, subtly influencing the geometry of the galaxy itself. They remind us that the universe is not a static backdrop, but a dynamic, flexible fabric, molded by the masses it contains. When we contemplate the spiral arms of the Milky Way or the elliptical forms of distant galaxies, we are seeing not just the collective light of stars, but also the invisible architecture imposed by their central black holes. The beauty of galactic forms is in part the handiwork of these invisible giants. It is tempting to think of supermassive black holes as cosmic tyrants, dominating their galaxies with overwhelming gravity. But a closer look reveals a more nuanced picture. They are not tyrants but guardians, ensuring stability amid the chaos of cosmic forces. Their gravity holds stars in place, their energy output regulates star formation, and their jets distribute the seeds of life. Without them, galaxies might collapse or burn out too quickly. With them, galaxies achieve balance, longevity, and order. Their role is not merely destructive but profoundly constructive. They are less like tyrants and more like ancient rulers, shaping civilizations from behind the scenes, ensuring that the great city of the galaxy can endure. Perhaps the most humbling aspect of this story is the recognition that we, as human beings, owe part of our existence to these unseen giants. Our sun, our planet, our very bodies are composed of elements forged in stars and spread by the outflows of galaxies shaped by black holes. Without the central regulation of Sagittarius A*, the Milky Way might never have sustained star formation long enough to produce a solar system like ours. Without the widespread distribution of heavy elements by quasar winds and black hole jets, Earth might have remained a barren rock. In a very real sense, we are children of supermassive black holes as much as we are children of stars. Their silent governance made possible the conditions for life, consciousness, and the ability to wonder at the universe itself. So when we gaze into the night sky and admire the beauty of the Milky Way arcing across the heavens, we are not merely looking at stars scattered randomly in the void. We are looking at a carefully shaped structure, anchored and influenced by the unseen power of a supermassive black hole. We are witnessing the handiwork of a cosmic architect whose presence is hidden but whose influence is undeniable. Supermassive black holes are not incidental to galaxies. They are their defining features, their silent hearts, their unseen rulers. They remind us that in the universe, as in life, the most powerful forces are often those we cannot see directly, but whose influence is written across everything around us. When we think about galaxies, it is easy to picture them as static collections of stars, dazzling spirals, glowing ellipses, or scattered irregular shapes suspended in the night sky like frozen fireworks. Yet galaxies are not still images. They are dynamic systems, living entities in cosmic terms, constantly changing, evolving, and responding to the forces that act upon them. At the heart of this evolution lies one of the most enigmatic influences in the universe: black holes. Far from being passive consumers of matter, black holes actively shape the life cycles of galaxies, guiding their growth, regulating their star formation, and even determining their ultimate fate. The life of a galaxy is not simply the sum of its stars and gas, but a narrative deeply intertwined with the activity and influence of its central black hole. To understand this, one must begin with the concept of galactic ecology. A galaxy is a system where stars are born, live, and die in an ongoing cycle. Clouds of gas collapse under gravity to ignite new stars. Those stars then shine for millions or billions of years before exploding in supernova, enriching the surrounding medium with heavier elements. New stars form from this material, and the cycle continues. On its own, this process might spiral out of control, with galaxies producing stars at furious rates until all their gas is used up. Left unchecked, galaxies might burn brightly for a short time before becoming barren and lifeless, cosmic deserts with nothing new to offer. Yet this is not what we see when we look across the universe. Instead, galaxies show remarkable balance. Some form stars actively, while others evolve more quietly, but few collapse into chaos. This balance is not accidental. It is the result of regulation, and one of the most important regulators is the supermassive black hole at a galaxy's core. When matter falls into a black hole, it does not disappear silently. Instead, it is accelerated and heated to extreme temperatures in the accretion disk, producing enormous amounts of radiation. In many cases, the black hole also launches jets of particles traveling at nearly the speed of light, stretching far beyond the galaxy itself. These processes release far more energy than the stars of the galaxy combined, making active galactic nuclei among the brightest phenomena in the universe. This energy has profound consequences for the galaxy. It can heat the surrounding gas, preventing it from cooling and collapsing into new stars. It can drive powerful winds that blow material out of the galaxy, reducing the supply of star-forming gas. Or in some cases, it can compress clouds of gas, triggering new rounds of star birth. In all these ways, the black hole regulates the pace at which stars are created, shaping the life of the galaxy. This regulation has been observed in many forms. In galaxies with very active central black holes, astronomers have detected large-scale outflows of gas, sometimes moving at thousands of kilometers per second. These outflows carry away the raw material for star formation, shutting down stellar nurseries and transforming active galaxies into quiescent systems. In fact, some of the most massive galaxies in the universe are red and dead, filled with old stars and little new star formation because their central black holes have effectively sterilized them. On the other hand, galaxies with less active black holes often continue forming stars at a steady rate, their black holes acting more as gentle regulators than harsh enforcers. This dual role, both creator and destroyer, makes black holes critical players in galactic evolution. The evidence for this influence extends to the relationship between black holes and the mass of their host galaxies. Astronomers have found that galaxies with more massive black holes tend to be larger and older, with less ongoing star formation. This suggests that black holes do not merely reflect the size of their galaxies, but actively shape their destinies. A galaxy with a voracious black hole may experience a burst of star formation followed by rapid quenching, leaving it with a population of old stars and little future growth. A galaxy with a quieter black hole may continue forming stars for billions of years, sustaining a longer and more gradual evolution. Thus, the character of a galaxy, whether it is a vibrant city of stars or a quiet retirement home, is deeply tied to the behavior of its central black hole. One striking example of this dynamic can be found in quasars, the most luminous type of active galactic nucleus. Quasars are powered by supermassive black holes consuming matter at extraordinary rates. Their energy output is so intense that it can alter the fate of the entire galaxy. Observations of quasar host galaxies reveal signs of violent winds and outflows, stripping away gas and halting star formation. This process, known as quenching, is thought to explain why many massive galaxies in the present-day universe no longer form stars. The quasar phase, though brief in cosmic terms, is like a dramatic turning point in the life of a galaxy, reshaping its future in a single burst of black hole activity. In this way, the black hole is not just a passive inhabitant of the galaxy, but an agent of transformation, determining how long the galaxy will remain fertile. But the influence of black holes is not always destructive. There is also evidence that black holes can promote star formation under certain conditions. When jets or winds from a black hole compress gas clouds, they can trigger the collapse of those clouds, igniting the birth of new stars. This process, known as positive feedback, may help explain why some galaxies experience bursts of star formation following periods of black hole activity. In this scenario, the black hole acts as a gardener, not just cutting back growth but also planting seeds for new creation. The dual nature of black holes, as both quenchers and enablers of star formation, underscores their role as regulators of galactic life, capable of steering evolution in multiple directions depending on the circumstances. The shaping role of black holes extends beyond individual galaxies to galaxy clusters and the cosmic web itself. In clusters of galaxies, hot gas fills the space between galaxies, serving as a reservoir for potential star formation. Without regulation, this gas would cool and collapse rapidly, fueling uncontrolled starbursts. Yet observations show that this does not happen. Instead, the gas remains hot and stable thanks to the influence of central black holes. The jets from supermassive black holes in the largest galaxies of the cluster inject energy into the surrounding medium, preventing it from cooling too quickly. This process, called AGN feedback, ensures that star formation across the cluster proceeds in a balanced way, shaping not just one galaxy but an entire community of galaxies. In this sense, black holes are not only guardians of their host galaxies, but also regulators of galactic neighborhoods, maintaining balance on a larger scale. Even the most dramatic events in galactic life, such as mergers, are shaped by black holes. When two galaxies collide, their central black holes eventually spiral together and merge, releasing enormous amounts of energy in the form of gravitational waves. These cosmic ripples spread across space-time, carrying information about the collision. At the same time, the merging black holes can drive powerful outflows that reshape the newly formed galaxy, determining how it will evolve. Thus, black holes are not only central to the quiet regulation of galaxies but also to their most violent transformations. They are present at every stage of galactic life, from birth to maturity to merger, always exerting influence, always shaping the path forward. From a philosophical perspective, the role of black holes in shaping galaxies is deeply profound. It challenges our assumptions about destruction and creation, about the relationship between chaos and order. We are accustomed to seeing black holes as destroyers, devouring matter and light without mercy. But the truth is more subtle. Black holes destroy in order to create balance. They consume matter, but in doing so, they release energy that shapes the galaxy, preventing chaos and ensuring longevity. They quench star formation, but in doing so, they prevent galaxies from burning out too quickly. They drive violent outflows, but those outflows distribute the elements needed for planets and life. In their paradoxical role as both destroyers and creators, black holes embody the dual nature of cosmic evolution. They remind us that endings and beginnings are often two sides of the same coin, that destruction can be a form of creation, and that the health of a system sometimes depends on the presence of forces that appear, on the surface, to be hostile. Our own galaxy offers a living example of this balance. The Milky Way continues to form stars at a steady rate, neither too fast nor too slow, thanks in part to the quiet regulation of Sagittarius Asterisk. If our galaxy's black hole had been more active, it might have quenched star formation long ago, leaving us without the sun, the earth, and life itself. If it had been less influential, the galaxy might have burned through its gas too quickly, exhausting itself before planets like ours could form. Instead, our black hole has played its role with quiet restraint, shaping the life of the Milky Way in ways that ultimately allowed for our existence. We are not just the children of stars, as the poet Carl Sagan reminded us, but also the children of black holes, shaped by their hidden governance of galactic life. The shaping of galaxies by black holes also raises tantalizing questions about the future. What will happen to the Milky Way billions of years from now, when it collides with the Andromeda Galaxy? The two central black holes will spiral together, merging in a cataclysmic event. The resulting outflows could reshape the merged galaxy, quenching some regions while igniting others. The life of this new galaxy will be guided by its central black hole, just as the lives of its predecessors were. In this sense, black holes are not only shapers of the present, but also of the future, guiding the destinies of galaxies across cosmic time. So when we look at galaxies in the night sky, we must see them not as passive collections of stars, but as living systems shaped by hidden hands. Their beauty, their balance, their longevity are not accidents. They are the result of regulation by black holes, the unseen architects at their cores. These black holes do not merely sit idly in the center, indifferent to the galaxy around them. They are active participants, shaping, regulating, guiding, ensuring that galaxies live not as brief flashes in the night, but as enduring cities of stars. They remind us that in the universe, as in life, the most powerful influences are often invisible, hidden at the center, shaping everything without being seen. Galaxies are the canvases, stars the paint, but black holes are the silent hands that guide the brush, shaping the masterpiece of the cosmos. When we look at the night sky, we see stars, galaxies, and the endless tapestry of space stretching farther than our minds can truly comprehend. But one question lingers: where did it all come from? How did the universe, with its billions of galaxies and trillions of stars, begin in the first place? For centuries, humanity has asked these questions, and modern science has tried to answer them through theories like the Big Bang. Yet, hidden within the shadows of space lies one of the most fascinating possibilities: that black holes themselves could play a role in the birth of universes. This idea is both bold and mysterious, for it suggests that the very entities we once thought of as ultimate destroyers may, in fact, be creators on the grandest possible scale. The traditional picture of the Big Bang tells us that about 13.8 billion years ago, the universe began as an unimaginably hot and dense point, then expanded outward, cooling and forming the structures we now observe. This expansion is still happening today, carrying galaxies away from one another like dots on an inflating balloon. But if the Big Bang was a beginning, what came before it? This is where things get tricky, because our physics begins to break down at the very first moments of the universe. The laws of space, time, and matter as we know them cannot describe what existed before that initial flash of creation. Some scientists, however, propose that perhaps the answer lies in black holes. A black hole is created when matter collapses to such an extreme density that gravity becomes overwhelming, pulling everything into a single point called a singularity. At this singularity, space and time as we know them cease to function. From the outside, we see only the event horizon, a boundary beyond which nothing can escape. But the interior of a black hole remains a mystery. What if, instead of being just an endpoint, a singularity could be the seed of something new? What if the collapse of matter into a black hole could trigger a kind of Big Bang inside, birthing an entirely new universe separate from our own? This is the basis of a bold theory known as black hole cosmology. According to this idea, every black hole might be more than just a cosmic graveyard. It could also be a cosmic womb. When matter collapses into a singularity, it doesn't simply vanish. Instead, the extreme conditions could cause space and time to pinch off from our universe and inflate into another. In this view, our universe itself may have been born from a black hole in some larger parent universe that would make black holes the ultimate creators, scattering baby universes across an endless cosmic family tree. One of the most intriguing aspects of this theory is that it could explain why our universe has the physical laws it does. Imagine if every universe born inside a black hole inherited certain traits from its parent, like the strength of gravity or the behavior of particles. In this way, universes could evolve just as life does. Some would collapse quickly, while others would last long enough to form stars, galaxies, and maybe even life. In this cosmic version of natural selection, universes like ours, stable, long-lived, and fertile with stars, would be more common because they are the kind that black holes continue to reproduce. This concept, sometimes called cosmological natural selection, paints black holes not just as objects within the universe, but as mechanisms for creating universes themselves. Of course, this idea challenges how we normally think about beginnings and endings. We usually imagine a black hole as the ultimate end of matter, where everything is crushed into nothingness. But if black holes can spawn new universes, then endings and beginnings are not separate. They are two sides of the same process. The death of a massive star in one universe could be the birth of a whole cosmos in another. This perspective is both humbling and inspiring because it suggests that creation and destruction are deeply intertwined at the most fundamental level of reality. While this theory is fascinating, it remains highly speculative. We cannot peer into a black hole to see what happens inside because nothing, not even light, can escape to bring us the information. Our physics breaks down at the singularity, leaving us in the dark. Yet mathematics hints at possibilities. Some models of general relativity suggest that the collapse of matter doesn't necessarily end in a singularity, but could bounce into a new expansion, much like the Big Bang itself. Quantum theories of gravity, which attempt to unite Einstein's relativity with the strange rules of quantum mechanics, also suggest that space and time might continue beyond what appears to be an end point. If these ideas are correct, then black holes could be bridges to new universes. This also connects to the concept of a multiverse, the idea that our universe is not the only one, but just one of countless others, each with different laws of physics and different histories. Black holes may be the portals that link these universes together. From our perspective, when matter falls into a black hole, it disappears forever. But from the perspective of the new universe inside, that same matter could be the raw material from which galaxies and stars are built. To us, it is gone. To another universe, it is the beginning of everything. The idea that our universe itself may have been born from a black hole in another cosmos reshapes how we see our place in existence. It means that our Big Bang might not have been the ultimate beginning, but just one event in a chain of cosmic births stretching backward and forward in ways we can scarcely imagine. It means that the story of the cosmos is not a simple line from beginning to end, but a vast, branching tree of creation, with black holes as the seeds. Beyond the scientific curiosity, there is also a philosophical beauty in this possibility. Black holes, which seem to embody darkness and destruction, could actually be the engines of creation. They remind us that appearances can deceive us and that what looks like an end may be the beginning of something even greater. They show us that the universe itself is full of paradoxes, that destruction and creation, endings and beginnings, may not be opposites but partners in a grand cosmic dance. As we push the boundaries of physics, building more powerful telescopes and probing deeper into the fabric of space-time, we may one day find evidence that supports or disproves these ideas. Perhaps we will see patterns in the cosmic microwave background, the faint afterglow of the Big Bang, that suggest connections to black holes. Perhaps we will develop theories of quantum gravity that reveal how space and time behave inside these mysterious objects. Or perhaps we will never know for certain, because the true nature of black holes will remain hidden from our reach. But even if we never have proof, the possibility itself is enough to spark wonder. In the end, the idea that black holes could play a role in cosmic origins changes the way we view the universe. No longer are they merely the villains of astrophysics, devouring everything in their path. They become something far more profound, creators, guardians, and shapers of existence. Our very universe could be the child of a black hole, and in turn, the black holes within our cosmos could be giving birth to universes beyond our imagination. When we reflect on this, we come face to face with one of the most humbling truths about science. The more we learn, the more mysterious the universe becomes. Every answer opens up new questions. Every discovery reveals new layers of wonder. And at the heart of this mystery lies the possibility that our existence is tied to the most enigmatic objects in the cosmos. Black holes may not just be shaping galaxies. They may be shaping reality itself. When we think of recycling, we imagine an earthly process, materials broken down, transformed, and used again in new forms. But in the grand stage of the universe, black holes may serve as the ultimate recyclers. To most minds, they are cosmic monsters that devour everything in their reach, swallowing stars, gas, dust, even light, and hiding them forever from view. Yet the deeper we study these enigmatic giants, the more evidence suggests they may play a crucial role in renewing the cosmos. They may not simply end the story of matter, they may write new chapters, redistributing energy, matter, and perhaps even information back into the universe in astonishing ways. The idea of black holes as engines of cosmic recycling begins with the way they feed. When a star wanders too close to a black hole, it is stretched and shredded by tidal forces, its gas spiraling inward in a dazzling dance of violence. This matter does not simply vanish quietly. As it falls in, it heats up and emits some of the most powerful forms of energy known in the universe. X-rays, gamma rays, and bursts of radiation shoot out into space, carrying energy across vast distances. In this process, what seemed destined for annihilation becomes a source of power, lighting up the cosmos. In this sense, black holes act less like pure destroyers and more like transformers, taking matter in one form and releasing it in another. At the centers of galaxies, where supermassive black holes reside, this recycling effect becomes even more dramatic. These giants, millions to billions of times the mass of our Sun, are often surrounded by swirling disks of matter. As the matter is drawn in, enormous jets of energy are fired outward, sometimes extending millions of light years. These jets pump energy into the surrounding galaxy, stirring up clouds of gas, triggering or suppressing star formation, and redistributing elements forged in earlier generations of stars. What falls in does not simply vanish, it is transformed into forces that shape the very structure of galaxies. In this way, black holes regulate the balance of creation and destruction. Without them, galaxies might produce stars too quickly, burning through their gas and collapsing into chaos. With their feedback, the jets and winds they generate, black holes act as regulators, slowing down star formation in some regions while stirring it up in others. The cosmic cycle of birth, death, and rebirth of stars owes much to this recycling mechanism. It is not too far-fetched to say that without black holes, galaxies would not evolve into the stable, long-lived systems we see today. The balance between destruction and renewal that they impose is essential to the universe's harmony. But the recycling role of black holes goes even deeper, to the very matter that makes up our bodies. Stars create heavy elements like carbon, oxygen, and iron in their cores. When those stars die, they scatter these elements across space, making them available for new stars, planets, and eventually life. Black holes, by devouring stars and matter, also contribute to this cycle. Their immense gravity gathers material, compresses it, and through violent interactions, redistributes it back into the universe in energized forms. The energy released in their feeding frenzies drives shockwaves through galaxies, mixing matter, spreading the ingredients of life across cosmic neighborhoods. Every atom in our bodies, the carbon in our cells, the oxygen we breathe, the iron in our blood, was forged in stars and spread across space through cycles of destruction. Black holes are part of this cosmic kitchen, stirring the ingredients, ensuring nothing goes to waste in the universe's endless recycling process. The question then arises, do black holes truly destroy matter? For decades, the assumption was yes, whatever crosses the event horizon is gone forever, but discoveries in theoretical physics suggest otherwise. Stephen Hawking proposed that black holes emit radiation, now famously known as Hawking radiation, meaning they slowly lose mass and can eventually evaporate. If this is true, then black holes are not eternal prisons for matter, but temporary keepers, releasing their energy back into space over unimaginable timescales. Even matter that seemed lost forever is eventually returned, recycled into the cosmos. This introduces a deeper and more puzzling mystery, the information paradox. According to the rules of quantum physics, information about the state of matter can never be completely destroyed. But if a black hole swallows matter, what happens to the information encoded within it? Is it lost forever, or does it somehow escape? Recent theories suggest that information may be imprinted on the event horizon itself, and that as Hawking radiation is emitted, the information is gradually released back into the universe in scrambled form. If this is true, black holes are not just engines of recycling matter and energy, but also guardians and redistributors of information, ensuring that nothing is ever truly lost. This would make them central players in the universe's deepest laws, upholding the principle of cosmic conservation. Seen in this light, black holes may embody a truth that resonates beyond physics, that destruction is not final. What appears to be an end may, in time, reveal itself to be transformation. Just as forests burn and regrow, just as seasons turn, so too does the cosmos recycle itself through black holes. Stars die, collapse, and feed black holes, which then return energy and matter to fuel the next generation of stars. Galaxies evolve under their influence, shaping the environments in which life can emerge. Even universes themselves, as some theories suggest, may recycle through black holes, each one a seed of creation in an endless cycle. The recycling power of black holes also has a poetic echo in our human imagination. We often fear endings, loss, and destruction, yet black holes remind us that endings can be beginnings, that nothing is wasted, and that even in the darkest voids, transformation is at work. They are metaphors for resilience and renewal, teaching us that even when something disappears from sight, its essence may live on in new forms. The light they emit, the energy they unleash, the structures they shape, these are the fingerprints of renewal hidden in what first appears as annihilation. As we continue to study black holes, building telescopes like the Event Horizon Telescope that captured the first image of a black hole's shadow, we may uncover more evidence of their recycling role. Already we know they power quasars, the brightest objects in the universe, releasing more energy than entire galaxies. Already we see their influence sculpting galaxies, regulating star birth, and spreading the seeds of matter. And already theoretical physics whispers of deeper mysteries, information preserved, universes seeded, reality itself recycled through these enigmatic engines. In the end, black holes may be the most profound symbol of balance in the universe. They take, but they also give. They end, but they also begin. They destroy, but they also recycle. The matter that falls into them may one day emerge again as light, energy, or even the fabric of another universe. The cycle continues endlessly, beautifully, across scales of time and space beyond human comprehension. So when we gaze into the cosmos and think of black holes as cosmic graveyards, perhaps we should shift our perspective. They are not only tombs, they are also wombs. They are the universe's way of ensuring that nothing is ever wasted, that every particle, every shred of energy, every spark of information continues its journey in new forms. In the vast machinery of existence, black holes may be the hidden gears that recycle reality itself, keeping the cosmos alive, dynamic, and ever-renewing. For as long as humanity has looked up at the night sky, we have wondered what lies beyond. Stars, planets, and galaxies inspire awe, but among all the wonders of the cosmos, few challenge the limits of our imagination like black holes. They are not simply physical phenomena, they are mysteries that force us to rethink our place in the universe, the laws of nature, and even the meaning of existence. Black holes are puzzles that unsettle us, pulling us to the edge of what we know, and then daring us to take one more step into the unknown. They remind us that reality is stranger than we dare to believe, and that the human mind, as powerful as it is, may only be scratching the surface of truth. To imagine a black hole is already to engage with paradox. Here is an object so dense that its gravity traps even light, the fastest thing in existence. To us, light is the very definition of freedom, moving across the cosmos at incomprehensible speed. Yet in the grip of a black hole, even light is a prisoner. How can we picture such a thing, a region of space where escape is impossible? The event horizon, the boundary surrounding a black hole, marks the point of no return. To stand at its edge in thought is to feel the vast power of the universe pressing against the limits of our reason. Beyond that line, time itself twists, space folds, and our understanding breaks down. We imagine it, yet we cannot truly comprehend it. That is the strange gift of black holes. They give us a glimpse of the infinite, but always one step beyond our reach. One of the ways black holes stretch our imagination is by showing us that time is not as simple as we think. In our daily lives, time feels steady, always ticking forward at the same pace. But near a black hole, time slows down dramatically due to the immense warping of space-time. If an astronaut were to orbit close to a black hole while their twin remained far away, they would age much more slowly than their sibling. To the astronaut, only a few hours might pass, while to the outside world, years, centuries, or even millennia could have slipped by. This is not science fiction, but the consequence of Einstein's theory of relativity. To imagine living in such a reality, where time itself becomes flexible, is to step outside the familiar and into a world where our deepest assumptions about existence are overturned. Black holes remind us that the universe does not conform to our expectations. Rather, we must stretch our minds to meet the universe where it is. Even more challenging is the singularity at the heart of a black hole, the place where our known laws of physics collapse. A singularity is said to be a point of infinite density, where matter is crushed into an unimaginably small space and gravity becomes infinite. Infinity is not something the human mind can truly picture. We can imagine large numbers or even vast stretches of space, but infinity defies us. To imagine something infinitely dense is to confront the limits of thought itself. And yet, this is what black holes demand of us, to hold in our minds the impossible, to contemplate realities that stretch language and logic to the breaking point. The challenge grows when we consider the possibility that black holes may not only destroy but also connect. Some theories suggest that black holes may serve as portals, linked to white holes. hypothetical opposites that spit out matter instead of consuming it. This connection could form what is known as a wormhole, a bridge across space and time. If such portals exist, they could link distant regions of our universe, or even different universes entirely. To imagine stepping into a black hole and emerging in another galaxy, or even another cosmos, is to imagine a level of freedom and strangeness that goes far beyond the boundaries of science as we know it. Yet these possibilities are born not from fantasy, but from the mathematics of relativity and quantum theory. Black holes stand at the edge where science meets imagination, where equations transform into visions of realities we can hardly describe. Perhaps the most profound challenge black holes pose is not to physics, but to our sense of meaning. We live in a world where endings are part of life, birth and death, beginnings and conclusions, yet black holes blur those boundaries. To an outside observer, matter falling into a black hole appears to freeze at the event horizon, never truly crossing it. From another perspective, the matter plunges inward and is lost forever, which is true. Both, depending on the viewpoint, this duality confronts us with the idea that reality itself may not be singular, but layered, dependent on perspective. It forces us to confront questions not only of what is real, but of what it means to know. If even the fate of a single particle depends on perspective, what does that say about the nature of existence? Black holes challenge us not only to expand our science, but to expand our philosophy. They also challenge us with their scale. The human mind is comfortable with objects we can see and touch, mountains, oceans, even planets, but a black hole the size of a grain of sand could outweigh a mountain, and supermassive black holes can hold billions of stars worth of mass. Their gravitational pull shapes entire galaxies, sculpting the structure of the cosmos. To hold such scales in the mind is to feel both awe and humility. We are small creatures, bound to a small planet, and yet our minds dare to imagine objects so vast and powerful they defy comprehension. Black holes remind us of both our insignificance and our greatness, for though we are tiny, our imagination reaches into the very heart of the universe. Another way black holes stretch us is by forcing us to face paradoxes that seem unsolvable. The information paradox is one of the most famous. Quantum physics tells us that information cannot be destroyed, while black holes seem to swallow information forever. Which law of nature gives way? This paradox has baffled scientists for decades, leading to new theories that information may be encoded on the event horizon or released through Hawking radiation. Whether or not these theories prove correct, the paradox forces us to stretch our thinking beyond current boundaries. It is a reminder that the universe may be far stranger than any one set of human rules can capture. Black holes pull us into these mysteries, demanding that we think bigger, deeper, and more creatively than ever before. Beyond science, black holes inspire art, literature, and imagination itself. They are metaphors for fear and desire, for endings and beginnings, for the unknown and unknowable. Poets and writers use them as symbols of despair or transformation. Artists depict them as swirling maelstroms of light and darkness. Filmmakers imagine what it would be like to fall into one, to travel through time and space. In this way, black holes challenge not only scientists but all of us. They call us to explore the boundaries of creativity, to use the tools of imagination to grasp what lies beyond reason. They are reminders that human imagination is itself a kind of universe, vast and uncharted, capable of reaching toward truths we cannot yet prove. In the face of black holes, we are forced to admit how little we know. They sit at the crossroads of relativity and quantum mechanics, the two great theories of modern physics, and highlight the gaps between them. They taunt us with secrets that our current science cannot yet unlock. And yet, this very challenge is what drives progress. By grappling with black holes, scientists develop new theories, new mathematics, new ways of seeing the universe. Each paradox, each unanswered question, is a door to deeper understanding. Black holes remind us that the unknown is not something to fear, but something to pursue. They fuel the restless human spirit that will not settle for ignorance, that longs to know even what seems unknowable. There is also a spiritual challenge in black holes. For some, they evoke dread, the fear of being swallowed by nothingness. For others, they are awe-inspiring, symbols of the vast mystery of existence. To look at an image of a black hole, as we did for the first time in 2019 with the Event Horizon Telescope, is to look at the face of the unknown itself. That glowing ring of light around a shadow is more than an astronomical picture. It is a mirror reflecting our own hunger to understand. It is proof that even the darkest mysteries can be approached by human ingenuity, patience, and imagination. It is a reminder that we are explorers not only of space, but of truth. In the end, black holes are more than objects in space. They are tests of the human mind and spirit. They ask us to imagine infinities, paradoxes, and realities that stretch beyond comprehension. They demand that we hold contradictions, that we accept mystery, and that we press onward despite not knowing. They force us to embrace humility, admitting our smallness even as they encourage our greatness, reminding us of the vast reach of imagination. When we gaze at the stars and think of black holes, we are reminded that the universe is not a finished story, but an unfolding mystery. Black holes are chapters we have only begun to read. They challenge us because they will not yield easily to understanding. They remain elusive, paradoxical, profound. And in that challenge lies their greatest gift. They awaken the boundless potential of human imagination, pushing us to dream bigger, think deeper, and accept that in the darkness of the unknown lies the light of discovery.